A theme of circle geometry is that special things happen when shapes are in circles. So a four-sided figure for year 7, in order to work with that, they need to know 3 of them so that they could add them up and subtract from 360 to get the third. The year 11 doesn't need that. If the 4 points are in a circle, and not all four-sided figures are in a circle, then you don't need to look at all 4 points at the same time, just look at them in opposite pairs. So if that's, I don't know, 70, that's got to be 110. If that's 60, that's got to be 120. So it's a great little aid to you. You don't need to look at all 4, you just look at them in pairs as long as the 2 angles in the pair are opposite each other. Also, whatever is inside in the opposite corner will be the same as the angle outside if you continue one of the lines along. Now, four-sided figures are called cyclic quadrilaterals. Any old four-sided figure in a circle is not necessarily a cyclic quadrilateral, so that is not a cyclic quadrilateral. Okay? Now, lots of good stuff happens with tangents. A tangent is a line that touches just once. So what I just drew there is not a tangent because it touched twice. This is a tangent. Now, cool things that happen with tangents are as follows. If you connect the point of contact to the center, you always get a right angle. Okay? Another good thing that happens with tangents is that, I'm going to pretend that's a tangent, even though that's pretty sloppy. If you continue 2 tangents on to an external point, the distance from the external point to the 2 points of contact must be the same. That's great because you then get 2 congruent triangles, both of which are right angles, which gives you lots of stuff to work with. What else is the case with tangents? Remember, for year 7, in order for them to work with this, you'd need to tell them that that was parallel to that, and then they could say that this was equal to that. A year 11 who knows circle geometry does not need that. Even if the lines aren't parallel, you can still work with this angle here. But the thing is, it's not equal to that one there. That's what the year 7 would say. It's equal to the other one. And this one here, it's not equal to that one, which is in the Z position in the alternate position. It's equal to the other one. So that means it's slightly annoying that this principle is called the alternate segment theorem. I would actually call it not the alternate segment theorem, because it's not about the alternate angles, it's about the other one, the one that it's not in a Z arrangement with. Okay, so I'll just show you an example of a problem. Okay, so let's just find some shapes. In pink, I see a triangle formed using a diameter, so that's definitely a right angle triangle. That pink triangle is also making contact with a tangent. I see in green a cyclic quadrilateral. Now, what good stuff might be enabled from that? Okay, well, we decided this is a triangle built using a diameter, so that's got to be a right angle, so therefore x has to be 68, I think. Well, 58, sorry. Is that right? They add up to 90, so it's got to be 68, sorry. Okay, now, this is a cyclic quadrilateral, so if that's 53, never mind all the other points in the green figure, just go for the one opposite. The one opposite has to add up to 180 with that one, so that's got to be 127, I think. So that is 127. That's 127 and that pink part of it is 90, then this part has to be 37. Just that part. And Now, what else can I do? I'm going to use the alternate segment theorem. Here is an angle between a pink triangle and a pink tangent. That's always equal to one of the angles in the triangle. Which one? Not the alternate one. Not the one that it's in a Z with. Instead the other one. So that whole pink angle there has to be 68. Which means that there, that black part of it, has to be 31. Because the 37 and the 31 have to add up to 68. I'm also going to use the alternate segment for this theorem for this one. If that's that is an angle between the pink tangent and the pink triangle, so it's equal to one of the angles in the pink triangle. Which one? Not the one it's in a Z with, not this one, but instead the other one. So that's 22. So that demonstrates the value of using D Mr. Examiner. Work stuff out even though you're not asked. So when I worked out this was a right angle, I wasn't asked for that. I just did it because it would get me part marks. And also just take some time at the start to go and find the famous shapes. I found a cyclic quadrilateral, I found a triangle built using a diameter, and I found a triangle making contact with a tangent. Find the shapes and then go and chase the angles around using the facts associated with those shapes.